Hi, my name's Scott Randell. I'm the manager of the AFX group inside the Visual C++ business unit at Microsoft. I'm here to talk to you today about how we've built the Microsoft Foundation classes. I'm going to cover some of the object-oriented design tenets we've taken and how we've implemented a lot of cool functionality inside of MFC. Here's the overview of my talk. I want to talk about some background to just get the terminology set for the rest of the presentation. And then, of course, the main focus is to talk about the class library design. What is MFC, how we've used object-oriented design tenets, C++ language, and how we built an infrastructure with the foundation classes. I'll go into a lot more detail of what is embodied in the foundation classes. And then in the last section, I'll talk very specifically about the MFC architecture and how applications built on MFC are structured. So let's first do a little bit of background here. This is some very simple concepts and a very brief overview of things you need to understand for the rest of my talk. This is not going to be an exhaustive discussion of any of these topics, so bear with me for a little bit. I'm going to talk about object orientation, all the classic principles of encapsulation, inheritance, polymorphism. I'm going to talk a little bit about Microsoft Windows. For those of you who've programmed Microsoft Windows, this is all old hat stuff. But once again, to get the terminology straight for the rest of the talk. Talk a lot about the core features of Windows, everything up to the new features of OLE 2. Object orientation. Let's start with the basics. Object orientation embodies a lot of things. Encapsulation is probably the most important. Encapsulation is pretty simple. You take your functionality, you encapsulate it in objects. Objects expose functionality through member functions, and objects usually contain state, usually stored in member variables. Very simple concept, of course. That's why we use C++ and C++ classes to encapsulate functionality in C++ code, which we can then use to create C++ objects. I'll talk a little bit about how we extend the C++ paradigms specifically to MFC. Inheritance, another important part about object orientation. In general, you have base classes and you have derived classes. Inheritance is the notion of a derived class inheriting behavior from a base class. Once again, a very simple notion, but a very important concept to understand when building an MFC application. We have classes which you can use as is, without having to do any inheritance, any derivation. But we also have classes where we require that you derive your own custom classes from a base class. This allows us to put a lot of functionality in the MFC base class that you normally don't have to deal with. And then you customize it in your derived class to add the functionality specific to your application. Last, and certainly not least, is polymorphism. Polymorphism is a pretty big word. What it really means is the ability of calling virtual functions on objects. In this particular example, we have onDraw, a virtual function that asks an object to draw itself. Parameter is a display context to actually do the drawing on. And in this very simple graphic, we show the notion of calling onDraw on a bunch of different objects. The important part about polymorphism is that it's the object itself that decides how to implement that function. The caller calls onDraw, the object decides how it's going to implement the functionality of onDraw. So let's talk a little bit about Microsoft Windows, once again to give you a little bit of a background to understand where the Microsoft Foundation classes come from. Microsoft Windows can be described in a variety of different ways. What I've done here is provided some very simple structure to explain the different levels of functionality inside of Windows. At the bottom here, we have the kernel services, those operating system services to manage memory, to handle processes and tasks, to handle file I/O, all the things you expect in a classic operating system. On top of that, we have a lot of graphic services in the graphic device interface, GDI layer. This is a very simple canvas-oriented model for drawing. GDI is very powerful and lets you use the same code to draw to the screen or to print to a printer. A very important notion for device independence. Layered on top of all this is the user component, the user interface component of Windows. It provides everything from Windows management to menus to handling all the dialogues and the dialogue controls that make up the main user interface elements of your application. The Windows API, the Application Programming Interface, is a C API. It uses the C language, and it provides a lot of functionality by using encapsulated handles. There are handles for Windows, handles for files, handles for drawing objects. As you'll see, we're going to turn those handles into C++ objects with the Microsoft Foundation classes. Of course, there are other parts to Windows, other Windows extensions, everything from ODBC, Open Database Connectivity, to access a variety of different database formats, to MAPI for mail services, to TAPI for telephony services, and the list goes on. Of course, one of the very important extensions to Windows is the thing called OLE, OLE, or Object Linking and Embedding. OLE is a topic all to itself. Here's an example of the kind of functionality you'll find inside of OLE. OLE provides a variety of functionality, and this diagram shows a lot of the complexity and a lot of the features provided through OLE. Of course, all you really need to know is about the component object model, the central plumbing, the mechanism by which applications and application components talk to each other. Built on top of the component object model is a variety of different interfaces, lots of functionality that you can add to your application and your components to provide more integration with container applications. For example, OLE automation lets you expose your objects to a scripting language, such as Visual Basic for applications. So what is this thing MFC? MFC, the Microsoft Foundation classes, is at heart a class library. It's written in C++. It provides a C++ API to Windows. Portability is obtained by layering the Microsoft Foundation classes on top of the Windows API. The Windows API being ported to a variety of different platforms gives MFC its portability. In addition, MFC is also an application framework, a framework on which you hang your code. Your code can be used to customize the functionality provided by the framework, to add to it, and to just use the functionality, the canned functionality provided in MFC. And of course, a very important notion is that MFC is an evolving class library, an evolving API standard. We've gone over time and evolved MFC from its original version, MFC1, layered on top of the Windows API, to MFC2, released with Visual C++, and our current version, current shipping version, MFC 2.5. As I speak, we're working on, of course, MFC 3, which will be layered on top of this diagram, and we have MFC 4 on the drawing board. This is a long-lived, evolving API that provides all the object orientation, the API encapsulation, and provides the C++ API to today's Windows and Windows of the future. I mentioned Visual C++. Of course, the Microsoft Foundation classes are a very integral part of Visual C++. Visual C++ provides the wizards and the development environment that makes it very easy to develop your MFC applications. That said, there's also other compiler vendors that support the Microsoft Foundation classes. So not only is MFC portable to a variety of different operating system platforms, it's also portable to a variety of different compiler implementations. Of course, MFC is also a good way to learn about C++, the language, general class usage, class design, the Windows API, functionality of Windows, OLE-capable features, how to build an application that provides all this functionality to users. What I'm going to do is explain some of the notions of our class design and how those apply to the Microsoft Foundation classes. So let's start with the C++ language. What we decided to use in MFC is what we call a sane subset of the C++ language. C++ is a very powerful, very feature-filled language. It's also an evolving language, as more and more features get added to the language over time. We decided to start with a simple subset, picked to be easy for people to learn, easy for serious programmers to use to develop their applications, easy for people to read code, as well as easy for people to write code. Of course, we have to support the basic tenets of object orientation, but we also want to take the features that are provided in C++ and build other conventions on top of them to make it easier to program at higher level than just the C++ language. It involves everything from naming conventions to how you structure your classes to how they work with the integrated development environment. Of course, the Microsoft Foundation classes, its source code, and all the samples follow these standards and follow the usage of C++, and you can get by with just learning this subset, sane subset of the C++ language. If you want to use other C++ language features, you of course are free to use them. We don't force you to learn about them. If you want to use them, that's your prerogative. So for example, some of the things that are in our sane subset are simple single inheritance. We have a very simple inheritance model. We use constructs which are familiar to C programmers. So for example, if something has pointer semantics, we use pointers. If it has reference semantics, we use references. Another important thing is to provide one way of doing things. Even though C++ provides many alternatives, we try and be consistent on the way to do standard things. Important point to note is we're not trying to make MFC a compiler test suite. There's lots of features in the language, lots of obscure ways of using C++. We've tried to make MFC accessible to a large number of programmers, and in doing so, we've stuck with this sane subset. One case where we've intentionally gone above and beyond the status quo compilers is in our support for exceptions. Even back in MFC 1, we designed our class library with C++ exceptions in mind. That's very important because even now, as we work on MFC 3, those basic design tenets of relying on exceptions make our APIs cleaner and more robust. As I mentioned, there's other things in the C++ language you may choose to use if you see fit. Things like multiple inheritance, virtual multiple inheritance, understanding all the dominance rules, C++ template syntax. These are all things you can use with MFC. We don't force you to learn about the more complicated syntax, and of course you don't need to learn about them if you don't want to. We also take the notion of public, protected, and private access control to one level higher. We take the C++ idiom and build a convention on top. So a typical class looks something like this. We have an area where constructors for the class are defined, where attributes, the properties of the class, are defined. These could be public member data. They could be functions, functions to get properties, functions to set properties. We have a structure for the operations, those functions that modify the object. We also have a section for designed overridables. These are member functions in the class, usually virtual member functions, which are specifically designed for you to override them. Of course, there might be other virtual functions in the class you might override, but these are specific member functions designed for overriding. They usually have the on prefix. Last in the list, you usually see this implementation section. This is functionality, which may be public, private, protected, that is the implementation of the class. These are functionality that may change from version to version of the class, and you should not be relying on it when you use this class. If you derive and customize a specific implementation of a class, you may start relying on some of those more implementation details. So to recap, in MFC, we've used some constraint in using the C++ language. We've added more conventions on top of standard C++, and done so using very portable C++ constructs. We've used abstraction where appropriate. We've designed our class library to be very efficient. And we've added features to make it possible to build very robust applications by supporting exceptions and a lot of built-in diagnostics as well. Let's go back and talk a little bit about encapsulation. An important notion in MFC is the notion of a C object. This is an object root which most classes are derived from. The C object class provides a lot of functionality. Everything from runtime type checking, enabling you to serialize, to save out the data inside your objects, a variety of diagnostics to build more robust code. And we also do typical C++ tricks like hide in copy constructor and operator equals so that people will not get default C++ behavior that they don't want. Of course, there's lots of other classes we have that are not derived from C objects. They typically are these primitive data types. They follow value semantics. For efficiency, we don't have virtual functions. They're just using the C++ syntax to get access to a data structure more efficiently. Of course, the most common examples of that are our string class, our rectangle class, time classes, simple little classes like that. Of course, there's lots of those handle-based objects inside of Microsoft Windows. And we take the same design approach to encapsulating most of those handles. So you take a C data type like an hwind, a handle to a Windows window, and we provide a C++ class, C++ data type, to embody, to encapsulate that functionality. In this case, we call it cwind. So if you're familiar with the Windows API, you're also familiar with the MFC classes. We make it very easy to convert from an H-wind to the appropriate C-wind. We also have a public data member if you have a C-wind to get to that H-wind. This is a very important part of the contract. A C-wind is an H-wind, so we provide all the functionality that you have inside a Windows window in the C-wind class. Of course, if you're writing to the C Windows API, you can call a variety of functions. On this particular example, we'll see how we can move a window around using an H-wind. And of course, the C++ version looks very familiar for those C programmers. For C programmers who handle Windows messages, they typically write a lot of switch statements. With MFC, we turn those switch statements into C++ member functions. So you're writing type-safe member functions to handle the messages sent to you by the Windows system. This general approach of encapsulating a Windows handle-based object is used throughout MFC, and we extend it to more sophisticated Windows services as well. Okay, now let's talk a little bit about inheritance. As I mentioned, most of our larger classes are derived from C object. We use simple single inheritance, all publicly inherited, so you don't have to worry about complexity of the C++ language. Our class hierarchy is designed to be relatively shallow, with classes designed for appropriate abstractions. We're not doing abstraction for abstraction's sake. So we've designed C++ classes which you can both use directly as well as providing useful abstraction you can derive from and customize. Here's a particular example showing probably one of the more deep parts of the class hierarchy. At the root is our C object class, the root of all of our major objects. Derived from that, we have the command target class. This is where command handling, the ability to handle commands and OLE automation requests come in. Derived from that is our CWin class, which of course is encapsulation of a Windows window. More specialized, we have the frame window, which provides all the frame window accoutrements for building an application window. And of course, you derive your own frame window from the frame window class, where you add functionality which is specific to your application. So let's talk a little bit about that polymorphism thing. Of course, we use virtual functions, standard way of getting polymorphic behavior inside of Visual C++. As I mentioned, we use our conventions layered on top of C++ to point users to where virtual functions have been specifically designed to be overridden. That's where the key parts of polymorphism come in. In addition to the standard C++ virtual function mechanism, we also have added what we call the message map functionality. This is a way to take Windows messages, control notifications, menu commands, and turn them into type-safe C++ member functions. These member functions are usually non-virtual, and they're usually extremely type-safe. This is a replacement of all those old switch statements you used to have to write in C. In addition to handling standard Windows messages, we can also handle control notifications and commands and command update UI messages. We do this through a two-dimensional mapping, which takes both a message or control notification and the source ID, where it came from, and once again, translates that into the type-safe C++ member function. As I mentioned, we take this basic message map notion and extend it. We've extended it for our command handling and our command routing mechanism, which I'll talk a little bit about later. We also extended it to do OLE automation, once again showing that the basic design tenets taken in MFC1 have evolved into today's MFC and MFC versions in the future. So let's go into the Microsoft Foundation classes in a little more detail. I'm going to go through the features of MFC in a couple of different ways. First, by the version of MFC to show you some of the evolution of the MFC API. And then I'm going to go through the categories of functionality. MFC 1.0, which we released in February of 1992, started the whole ball rolling. The design decisions we made in MFC 1 are continuing on even today. We started with our sane subset of C++. We started with our encapsulation of the Windows API for the C++ programmer. We also provided a lot of the standard user interface idioms, user interface parts you had to do to build a Windows application. Of course, we started out being compiler independent. We also designed our class library to produce small, fast executables. We're trying to make C++ pervasive in the developer community, and back in MFC 1 days, a lot of people were still programming in C. Of course, portability to different platforms is important, including 16-bit Windows, Win16, and Win32. With MFC 1.0, of course, you could just recompile to get platform portability. And this sort of started the ball rolling with MFC evolving with the operating system, way back in MFC 1 days. With MFC 2, we took all the things we had in MFC 1, we didn't throw it away and start over again on our second system. We took the design decisions we made in MFC 1 and extended them. We provided a high degree of backward compatibility, so those MFC 1 applications continue to run. We added architecture classes to build more of an application framework. I'll talk a little bit about that later. We added lots of high-level abstractions, components that you can use, incorporate into your application, get lots of functionality for very little effort. Of course, part of our second version is to listen to what our customers thought about our first version, and we do this continually. We listen to our customers, and we get requests for new features. The MSC version 2 is about 100 classes, a little more than 100 classes, and about 60,000 lines of code. We, of course, provide everything in source code form, so you can use the Microsoft Foundation classes to learn about C++ and learn about Windows programming as well. Our currently released version, MFC 2.5, does the same thing. It builds on the previous version, MFC 2.0, which is now becoming the accepted industry standard for writing to the Windows API. Provide the same degree of backward compatibility, and we add a variety of new features. Primary ones for MFC 2.5, of course, are our database support through ODBC and our OLE 2 support. And I'll show you a little bit about that later on. Another way of looking at the functionality inside of MFC is to look at the different components, the different subsystems inside of MFC. This diagram tries to illustrate that we have a layered approach, building on top of our general purpose classes, our Windows API classes, adding all the architecture and the high-level abstractions on which you add your code. So let me go through each of these categories and describe the kind of classes and the kind of functionality we have provided to you in the Microsoft Foundation classes. At the bottom, we have a lot of general purpose classes, classes you use whether you're programming to Windows or not. We provide in our CObject class runtime type information. We provide a model for object persistence, the way you save out the data for your object and read it back in. We supply a variety of data structures implemented in templatized collection classes. Of course, we provide a lot of primitive data types like strings, time and date. We provide a simple abstraction of file so that you can save data to real data files, compound files, or to files stored in a database. And as I mentioned, we built our exception handling mechanism into the core of our classes. Layered on top of our general purpose classes are our Windows API classes. Support the standard application things you need to do, everything from window management, menu management, graphics drawing, all the differences between SDI and MDI, frame windows, UI standards, all that's encapsulated in our Windows API classes. Of course, we are extending that to provide new controls and new user interface idioms as the operating system evolves. Layered on top of that are our architecture classes. I'll go into some of these in more detail a little later, but we provide a document view architecture, an architecture for routing your commands through your application, architecture for doing a lot of common things you need to do in an application, whether it be printing, whether it be getting information in and out of dialogues or in and out of databases, or whether you want to support context-sensitive help throughout your application. MFC provides the architecture and the framework on which you can add these features to your application. And of course, we provide lots of high-level abstractions, components, code you can use and incorporate in your app. We provide control bars, everything from toolbars to status bars. We provide a very simple architecture for implementing scrolling and splitter windows. We have can form views for laying out your user interface for form-based applications, and support for data-bound views as well, bound to information stored in an ODBC database. Make it easy to build editors, make it easy to incorporate VBX 16-bit controls, and then of course we have lots of support for OLE 2.0. In our MFC OLE support, we support all the different features of OLE. Everything from OLE automation as a client, calling an OLE automation server, being an OLE automation server, exposing your functionality to other clients. support all the visual editing features, being containers, being servers, and all the other support of compound files, drag drop, uniform data transfer, all provided inside the MFC OLE classes. A lot of functionality is already implemented for you inside of MFC, so you don't have to do a lot of this work yourself. So let's go into more detail describing the Microsoft Foundation classes, the architecture of the class library, and the architecture of applications built on top of MFC. For an example, I'm going to use the Scribble tutorial sample. This is a sample provided with MFC that lets you learn about MFC and Windows programming by starting from scratch using the Visual C++ application wizard, creating an application skeleton, and over time adding more features until you have a very full-featured application. I'm then going to go into some details of the architecture, covering documents and views, our command routing architecture, and other architectural things that are part of MFC. Talk a little bit about our data exchange paradigms, other high-level abstractions, those components you can use, and of course talk a lot about OLE too. When we created our new application, these are the classes created by the application wizard. There are four main classes. The main application class, derived from CWinApp, provides all that glue necessary to build an application. We have a frame window that contains all the toolbars and status bars. And then we have a document class and a view class. These two classes are tied together and provide the doc view part of our application. Now let me show you the result we get with building step 0 of our Scribble application. And this is all what you get for free thanks to the functionality of the Microsoft Foundation classes. Let's go over to our demo machine and show the results of Scribble step 0. Here it is here. We have a full-featured Windows MDI application. And as you'll see, there's a lot of menu commands which are already provided and implemented for you by the Microsoft Foundation classes. Everything from document management to printing, print preview, to managing your edit menu. You'll notice here some commands are disabled because we haven't implemented them yet. Once we implement those commands, the menu items will automatically become enabled for us. Of course, there's lots of standard commands for managing your control bars, your toolbars, turning them on and off. Since it is an MDI application, we support all the MDI commands canned in the Foundation classes. If we'd wanted to choose online context-sensitive help, that's also enabled by the Foundation classes. So all this functionality you get without writing any code. Now let's go back and talk about how we can add code to customize our application and do something interesting in our view here. Right now, you'll notice we actually don't do anything in this application yet. That's unique to this application. The main architecture we use for adding functionality to your application is this thing we call document view, or doc view. It's a very simple notion of splitting functionality into two classes, two halves. The document half, the data half, and the view half, the user interface half. We have a class that contains the data and exports the data functionality to the view. The view takes that data and functionality and exports it with a very specific user interface to the user. We do that through two classes, a base class for the document called, you guessed it, CDocument. The base class manages a lot of the stuff you'd normally have to do yourself. It supports all the disk file persistence. It lets you hook in your data to a database or into an OLE compound structured file. Make it very easy to extend the functionality of the class and make it very easy for you to get a fully featured class without doing a lot of work. A good example of that is how we support serialization. You implement the one serialized member function in your CDocument class, and all the rest of loading and saving files is done for you by MFC. Similarly, for your views, your user interface, we have a class called CView. CView is derived from CWind. It is a very simple child window. Inside that window, you draw your user interface and you interact with the user with keyboard and mouse. This view class can be used in a variety of different places. It can be used in a simple single document interface frame window, an MDI frame, or it can be used in place using OLE visual editing. Since we separated the document and the view into two different classes, that allows us to have multiple views that talk to the same document. We also make it very easy to implement more sophisticated features in your view, to optimize painting, to support print preview, and so on. That printing is a good example where we've taken the basic architecture in doc view and extended it. And we've extended the GDI functionality to provide a more abstract drawing model. Makes it easy to implement a full-featured print preview without writing any specialized code. This little code fragment shows you a very simple way of drawing to your view. The same code is used for drawing to the screen, to printing to the printer, or for drawing in print preview mode. So let me show you some of the features that I've just described in the context of our Scribble application. So here's a later version of the Scribble tutorial application. You'll notice there's lots of new functionality we've added in the application. You'll notice there's new commands on the toolbar, there's new menu items. We've implemented real code in drawing the view. This is the view of our application. In this particular application, the Scribble application, the purpose of the view is to draw scribbles. And I'm artistically going to scribble in this view. The view handles the mouse clicks, the user interface actions, and stores the scribbles, the little strokes, in the document. The canned MFC implementation makes it very easy to save out the information in the document in a data file. The canned implementation of MFC makes it easy to load that information back in, makes it easy to support multiple views on the same data. So for example, I can create a new window viewing that exact same data. As one view changes, other views get synchronized as well. So things that would normally be very hard to do if you had to write them all from scratch yourself are made very easy by exploiting the functionality of the foundation classes. We also support splitters, so you can split the view into multiple views on the same data in the same window. There's lots of user interface features you get for very low cost thanks to the MFC architecture. Of course, one of the better examples is our printing support. We can print these scribbles, or we can use the canned implementation of a full-featured print preview. Support zoom in, zoom out. By using that same function to draw to the screen, we use the same code to draw our scribble in our print preview mode. The rest of the implementation of print preview here, zooming in and zooming out, is done for us by the foundation classes. It's amazing what you can do when you have the power of the object-oriented MFC behind supporting your application. So that's a quick overview of our doc view architecture. Another important architectural notion is the notion of a command. Command is an instruction, usually from the user, to perform a specific action on an object. We've layered this on top of our MFC 1.0 message map architecture and layered it also on top of the Windows WM command message. We've made it possible to implement the command in any given class. We've also made it possible for any given class to update the user interface. What that means is whether a menu item is currently enabled or disabled can be handled and written in a very object-oriented, type-safe fashion. As your user interface changes from menu items to toolbar buttons, you don't have to rewrite any code. We also support command routing. Command routing is the notion of a command message coming in, normally to a frame window, and having a very clear architecture by which that command gets routed through the system. In this particular case, in an MDI window, the frame window gets first crack at the message. It usually delegates it to the currently active MDI child window, which then sends it to the view. The view handles most messages. If the view doesn't handle it, it sends it to the document. If no one really wants a message, last chance gets sent to the application. So this very simple notion of just having a structured way of routing messages makes it very easy for you, the class designer, to decide where the message should be handled. Which class is the best class for handling this particular command? So let me show you some of the features of our command handling and command routing architecture by using our Scribble example. So here's our simple Scribble window. The menu item commands get routed through the application framework. Create a new window. We now have an active view and a document behind that view. Some commands are handled by the view. For example, being able to draw on the screen, all the menu and keyboard user interface usually gets sent to the view. Handling things like storing data, such as saving out the document, is usually handled by the document. Some commands, like application help, are handled by the application object. Other commands, like the MDI window, are handled by the MDI frame window. The nice part about this command handling and routing architecture is the same command can be present in a couple different user interfaces. For example, file new on the menu calls the same code that file new from the toolbar calls. So you write the command handling code once, and regardless of the new user interface you layer on top of it, the same underlying code still works. You'll also notice that some of the menu items are disabled. This goes through our command update mechanism. If there is currently not a command handler active for a given menu item, in this case cut, that menu item is automatically disabled by the framework. Another important architectural underpinning is the notion of getting data in and out of user interface. Dialogues, forms, database-bound forms are all examples of user interface that you want to get data in and out of. We do that through DDX and DDV, our dialog data exchange and dialog data validation mechanisms, a way of getting data from your objects into the user interface, and then once the user has committed an action, to get that data back from your user interface into your objects. This diagram tries to show how we use the DDX mechanism to get data out of your document or view, where it's stored as simple member variables, into a dialog or form object, where it's also stored as simple member variables. The automatic DDX and DDV mechanism takes that information out of the C++ object and puts it into the active dialog or form. In this case, we have a dialog, so when the user hits the OK button, the automatic DDX mechanism will take the values out of the dialog controls, do validation, and if successful, store those new values in the dialog or form C++ object. You can then do an additional level of validation to update the values of the true data stored in your document or your view. So let me show you some simple examples of how we use this mechanism for both simple dialogues and more complicated database forms. So here we are at our Scribble application again. We have a simple dialog and a simple user interface for changing the width of a particular pen. And that's done through a very simple dialog. The DDX mechanism is used to move two integer values from the C++ object into this very simple dialog. So there's a very simple case of how we use DDX for dialogs. Let me run a more complicated case of where we use DDX and our database classes to build a more sophisticated front end. This is another one of our MFC sample applications we provide in tutorial form. It's called the enroll sample. And this particular example is a student registration little database stored in a Microsoft Access file. The user interface to enroll is very simple. You can see here it is a form. You can see the fields of the form, and you can scroll through the database records by using the toolbar or using the menu items. This is also an example of a more sophisticated form-based user interface because we have drop-down lists that the user can select from to learn about who's teaching Math 201. We also have more sophisticated views to get more detailed information on a particular course, how long it is, and so on. So this is an example of how we can take the data exchange architecture and build on top of it a very sophisticated data-bound form. Where there's some of the architectural underpinnings of a simple MFC application. As we add more sophisticated functionality of OLE2, we will see how we add more and more classes to implement this more complicated, more feature-rich functionality. As I mentioned, we support everything from OLE automation through OLE visual editing and all the other very cool features of OLE. And we do so by very specific classes layered on top of our application framework. So for example, for OLE automation clients, those applications who want to drive OLE objects through a scripting language, you can use C++ as your scripting language. You can write applications in C++ that drive other OLE automation capable objects. We do that by providing type-safe C++ classes to talk to those objects. You end up writing a hybrid C++ VBA application that lets you drive applications, let's say Microsoft Excel, from type-safe C++. Of course, we make it possible to build those OLE automation servers. I mentioned the command target class. That's where the functionality for OLE automation has been added. Any class derived from command target can be an OLE automation server object. By exposing your member functions as OLE automation methods and your member data as OLE automation properties, you can take your C++ classes and expose them to other scripting languages, to other applications in a very easy-to-use, programmable way. Once again, by using the same architecture we had with our MFC message maps, now through dispatch maps. Well, then there's visual editing. Of course, the real cool visual part of OLE is the fact you can embed one application's user interface inside of another application. We support building the containers. Instead of deriving your document class from cDocument, you derive it from COLA document. If you want more sophisticated features, you can derive it from another specialized class for supporting links to embeddings. We also provide an architecture for building the items in your application. Items are those rectangles you draw in your container application that contain the user interface from other applications. And I'll show you an example of an OLE visual editing container in a minute. Of course, we also make it possible to build OLE visual editing servers. Once again, instead of deriving from COLA document, you derive your server from COLA server doc. That base class provides a lot of functionality that you normally have to do yourself, but we've provided with MFC so you don't have to add the OLE specific functionality. Similarly, we have an architecture for adding items. In this case, these are those objects you want to expose to other container, other client applications. And we also layer on top of our existing MFC2 architecture to make it very easy to create these objects, to control their lifetime, to provide more sophisticated custom user interface on top of them. So all the toolbar and menu bar negotiation, which is done in OLE applications, is provided for you in the Microsoft Foundation classes. You just have to implement a few virtual functions in your classes, and the rest of the glue and the plumbing is done for you by MFC. So let me show you an example of an OLE visual editing server. What we have is we've taken the Scribble tutorial example. Now we're up to step 7 here. We've taken an application that was written without OLE in mind. We've added OLE server capabilities, once again in a tutorialized manner. So let me show you that application. In fact, this is it. From the user of this Scribble application, nothing really has changed. The interesting thing is we can now embed this user interface in a container. So let's use another MFC sample as an OLE visual editing container. This is another MFC sample provided in source code form with the Microsoft Foundation classes. And this is an example of what a draw application needs to do in the 1990s. Of course, it's a standard draw application. You've probably seen or written one of these yourself. It draws rectangles, it draws rounded rectangles, and so on and so forth. What makes this a really interesting draw application is it also supports OLE visual editing. We can insert any OLE objects we want. In this case, we're going to insert the Scribble file type from our Scribble application. And what you'll see is embedded in our draw container application, we have the Scribble user interface. Here's the Scribble canvas. Here are the Scribble toolbar buttons for changing the line thickness. These are the Scribble menus, all inside my container application. That makes it very easy to build reusable user interface components, embed them in a variety of different containers. Now, of course, this basic concept of embedding an external object in your user interface is not restricted to just MFC applications. Let me pick another object that's installed on my system. Well, let's say a Microsoft Excel chart. Just like we did with our Scribble object, we can embed Microsoft Excel inside of our container. When we embed it in there, all the Microsoft Excel user interface is now available in our Olay container application. So you'll notice all the Excel features of Excel tooltips and Excel toolbars are now available in our little draw app. Now, of course, this is an MFC container, so all the features you know and love in MFC apps still work if you support Olay. So if we go into print preview, we'll print preview those objects we've built into our application, the Scribble object, and the Excel object, all with the same code. So we've covered a lot. We've gone through some of the issues of class design. We've shown how we use C++ and our usage conventions. We've shown how we can make a practical use of the object-oriented concepts and how we can apply those to writing serious, professional, robust Windows applications. We've shown how we can take these basic concepts and evolve them and add more and more complex features while still providing a lot of backward compatibility. We've talked a lot about the architecture classes, the infrastructure for not only the rest of MFC, but the infrastructure for your application as well. Lots of high-level abstractions, those building blocks that provide functionality for your application that you don't want to write yourself. And what have we learned about MFC? Well, MFC, the C++ Windows API, provides a lot of that underlying architecture, provides the implementations of those high-level abstractions, provides a portable API for writing serious applications. We continue our tradition of still producing the smallest and fastest executables and protect the long-term investment of people writing to the MFC API. And I hope you've seen that it makes it easy to learn about C++ and Windows programming, thanks to the combination of the Microsoft Foundation classes and the Visual C++ product. So that's all I have to say about MFC today, seeing the underpinnings of our current products and also the underpinnings of where we're going in the future. Hope you found this interesting, and thank you very much for your time.